we are now 5 participants and two people from the library. And we thought there would be maybe about 25 persons coming, so we could check. People entering. Will people have people entering now? But it seems that no further person is there. Maybe I introduce myself very briefly. My name is Hedwig Becker, and you got emails from me, or you will get also another email from me after this course. I'm just kind of doing a kind of moderation here, and I will send you the presentation of this course afterwards. And if you need a confirmation of participation, please let me know by answering to the email in which I send you the presentation. This would be best. And so I can do them very quickly, one after the other, and send you the presentation. This is my part here. Now I would give the floor to Katja Kessler, who will give you the contents of this course.
Yes, thank you. So hello and welcome from my side. I'm Katja Kessler, and I work at the Research Service Center of the University Library. I would like to start with this cartoon, which depicts very well what could happen if you don't take care of your research data. So your data could be lost for future reuse and research. And today you will learn how to avoid such scenarios, and also how you and others can benefit from a proper research data management. The topics which we will cover in this course are the following. After an introduction to research data management, we will discuss the FAIR principles. Then I will present to you important aspects of research data management, including the planning, documentation, storage, and publication of data. Then we will discuss relevant guidelines and policies, and in the end, we will inform you how the library can support you. By the way, you can leave your camera on. That's very nice, actually. And if you have any questions, you can always interrupt. Yeah,
Thanks.
great.
Thanks, that's very nice.
Yeah. So let's start with the question, what is research data? Generally speaking, it is all the data generated during or as a result of a research process. Here you can see a passage from the Dfg guidelines on the handling of research data, and they enumerate different kinds of research data like measurement data, laboratory values, text, surveys, and so on. And the important aspect is always the relation to scientific research. And it can also depend on the discipline and the object of research if something can be considered as research data or not. There are different ways how you could classify data. Today, we will focus on digital data in contrast to analog data. Another important distinction are primary data, that is the data you create and collect, in contrast to secondary data, which are reused. You can classify data according to data types, methods of creating or collecting data, and by the data format. And furthermore, you can distinguish between quantitative and qualitative data. And the handling of your research data also depends on the category of your data. So for example, if you deal with archaeological findings, you need space, the right temperature, equipment to conserve it, or if you reuse other people's data, you have to respect the license conditions. And if you create data which is very difficult or even impossible to reproduce, then it's particularly important to save the data. The stages of research data management can be illustrated with the model of the research data lifecycle. So this lifecycle describes all the stages of data throughout a research project, and it covers all the stations of a systematic handling of data. So it starts with the planning stage, then creating or processing the data. Here it's, for example, important to document what you're doing. Then think about how to preserve your data, which of your data should be archived and how. And in case you share your data, it can be reused for further research, and that is how the life cycle of research data continues. There are various reasons and motives for research data management. First and foremost, research data management aims to ensure reliable verification of results, which increases the integrity and reproducibility of research. And besides, others can reuse or build upon your research data, which makes the overall research process more efficient. Early research data management can also call your attention to potential problems like data loss. So ideally, you still have enough time to outline solutions. And one of the goals is also to improve the findability and reusability of data by other researchers, colleagues, and also regarding your own future research, because research data management ensures the data is well organized, described, and securely stored. And actually, very often the motivation are policies of institutions, for example, here of the Technical University of Munich, or of research funders who also intend to increase the integrity, reproducibility, and efficiency of research. Here are some facts and figures which illustrate the need for research data management. According to a survey on reproducibility in 2016, most scientists failed to reproduce someone else's research results. That is the deep red color. And more than half of them also failed to reproduce their own results. Then more than a third of the respondents work in labs that have not established any procedures of reproducibility of their experiments. And they also indicated factors which contributed to the irreproducibility of research, factors like selective reporting, which means that results are not fully or accurately reported. Besides, the methods, code, or raw data are often not available, although they are indispensable for the reproducibility. And these are the reasons why you should take care of research data management. Even if it takes some time at the beginning, you will see that in the long run, it will save you and others a lot of time, money, and trouble. The important aspects of research data management are very well summed up in the so-called FAIR principles. Probably you have already heard of them. FAIR is an acronym which stands for findable, accessible, interoperable, and reusable. The FAIR principles were published in 2016 by Force 11. This is an association of researchers, librarians, publishers, funders, whose aim was to increase the value and reusability of research data. Hello. And yeah, we will have a look at the FAIR principles and what they mean exactly, starting with findable. So metadata or data are assigned a globally unique and persistent identifier is the first principle. That could be, for example, a DOI, a digital objective identifier, which is very widely used. And those identifiers are often assigned by repositories where you publish your data. Then data are described with rich metadata. Metadata are data about data, so they describe the data and help to find them. Often metadata and data are separate files, and the metadata contain the identifier of the data. And metadata or data are registered or indexed in a searchable resource that could be the repository itself or a search engine. In order to make the data accessible, you should ensure that data or metadata are retrievable by using a standardized communication protocol, which should also be open, free, and universally implementable. The protocol should allow for an authentication and authorization procedure where necessary. So here you can see that FAIR does not necessarily mean that all data must be openly accessible, but the access conditions should be specified very clearly. And the metadata should be accessible even when the data is no longer available. Now I can also show you an example of a data set. So this is a data set in Mediatome. That's the institutional repository of the Technical University of Munich. And regarding findability, you see all data sets in Mediatome have an URL, which is a persistent identifier. And besides, you can also get a DOI, which is often required by journals. The data are described with rich metadata. So here you can find a lot of information about the data. You even have a description. And the metadata are indexed in a researchable resource. The resource is the repository itself, in this case Mediatome, but also Google, because all entries in Mediatome are also indexed in Google. Yes, and about accessibility, here the standardized communication protocol, HTTPS, was used. There are several download possibilities, also via FTP. So here all these two principles we discussed are fulfilled. So then let's continue with interoperability. This means that different systems are compatible, they can work together, and to achieve this, controlled vocabulary has to be used. That could be, for example, a predefined word list or special fields which you use to describe your data. And these vocabularies should also follow the FAIR principles. And in order to make clear how different data sets are related to each other, you could also include qualified references, so links to maybe an article or another data set. Metadata are not only important for the findability of the data, but also for the reuse, because you need a good description and context information in order to interpret the data correctly. And that's why metadata should contain all the relevant attributes like context information, experiment procedures, conditions, etc. And besides, you should state under which conditions the data can be reused, for example, by using a license like the Creative Commons licenses. Indicate the provenance of the data, so where the data created or collected, and if applicable, use domain relevant community standards like metadata standards or standards regarding data formats or archiving. I can show you again the example. So here interoperability is achieved by using predefined fields. So machines know exactly, for example, that behind document type, you find the information about the type or the author. So this is the data site standard, which is used in Mediatome. There are different levels of interoperability. So for a complete automated interpretation of your data, you would need even more complex controlled vocabulary. And here you can also find a reference to another, publication, which you can include. So you have everything together, what belongs together. And regarding reusability, here you can also see the license condition CC BY, which means that you have to state the author. Yeah. And a description and method of assessment also helps you to understand and interpret the data correctly, which is necessary for reuse. Okay. Do you have any questions so far? So this was just an overview of the FAIR principles, but you will learn more about them in detail because all the aspects that we will discuss now also help to achieve the fairness of data.
Can I ask you?
Yes.
Yeah. I'm not a Tum employee, but I work on in consortium with Tum colleagues in the international project. And if we will have a publication or data set, who will how set up identifiers in Tum media in Mediatome?
In Mediatome.
And what is the procedure?
Yes, I can show you right now. So. Do you see the screen or did I stopped it here now? So on our website, you find research data, archiving and publishing, and then how to publish research data on Mediatome. And here the procedure is described. So for example, at the beginning, you have to fill in a request form. Then we will check it. We will send you a link to upload the data. We also require a checksum. And then, yeah, we will guide you through every step. There are also different options, like you can get a DOI or a concept DOI, or if you need a review link, we can all discuss these features if you need them.
Okay.
Any other questions? If not, we will continue with the planning and organization of your data. And you can plan the handling of your research data by writing a data management plan. This is a document which describes the future handling of your data. It ought to be done very early in the research process. And as research rarely turns out as it was planned, it is also a good idea to update the data management plan regularly, for example, every 6 months. A lot of funding organizations also require a data management plan already when applying for research funding. And even if you're not applying for funds, it's a good idea to write a data management plan because it helps you to identify potential problems at an early stage so you can still find solutions. Here you can see the components of a data management plan. So it should include administrative information about the project and the responsibilities, and then also a description of the relevant data, like the data type, format, amount, and the software needed to create or access the data. You should specify how you organize your data. Also regarding data storage and backups. If applicable, you should consider ethical and legal issues, for example, when dealing with sensitive personal data. And at this early stage, you should already think about long-term preservation and data sharing, selecting a suitable repository and license. So this slide is just an overview of different tools and templates which can support you when writing and updating a data management plan. First of all, you have here the Tum Workbench, which supports you in various aspects of research data management. We will have a closer look at it at the end. And there are also several other tools listed here, which you could try out. One aspect of data organization is a clear hierarchical folder structure, especially if you're dealing with a lot of different data sets and if you are collaborating with other researchers who should also easily find and store the data in the respective folder. So it might be a good idea to name your folders according to the work areas and processes within a project. There's also a nice tool for a standardized folder structure called Gintonic. It is a default file organization and file sharing system, and it's based on an open source software developed by 3 German research centers and the NFDE for neuroscience. And the idea is to provide a commonly accepted template for folder structures, with the advantages that, first of all, you don't have to think about how you want to name your folders. And secondly, it facilitates collaboration if everyone uses the very same folder structure. The naming of files also plays an important role when organizing your data. Here you can see an example of 3 options for file naming. And I would like to ask you which of those you would prefer. So you can just unmute yourself and explain your choice. You can also say which option you would not choose. Yes, Benjamin.
I guess the C is the best. I mean, I would go with C probably.
With C, and why?
Well, I think it's a bit more clear. I mean, for instance, compared to A, well, this is old version, but doesn't make clear. Old version is a bit vague. I mean, right, it could be several old versions. The date format could be confusing. Could be read both sides. So I don't know if it's made in 2011 or 2019. The second one doesn't tell me much unless I'm really familiar with the file. So I said the C is clearest, at least since obviously it's not any of my files. That I understand what is in the file.
Yes. So one aspect was the version. Of course, V1 is better than old version because then you will run out of names if you begin with old and older and even older version. And you're right, B is not so clear about the content. So it's better to choose a title which gives you some information about the content. And about the date, well, you should stick to a date convention. So if you're collaborating within a group, then everyone should use the same convention. So in this case, it's year, month, day. Okay, I have another example. Maybe someone else wants to say which option is best. Or is there one option you wouldn't choose, and why?
I think I will go with the B.
Yes, and why?
Yeah.
It's correct. And why did you choose B?
Well, the only thing that I can separate it from C is that they use the numerical number than the alphabet, so the March. So it's shorter and more clear, probably.
Okay.
And then with the hyphen again, separate the date from the attachment.
Okay, you have the hyphen. So I think also that B is a good option. About the date, I mean, the other 2 date conventions are also fine. You just have to agree upon them. There are 2 other hands showing up. Do you have comments? Yeah.
I think B is correct because it's very important to use these special characters between the numbers in order, from an IT perspective, in order to browse around and find files very specifically. So it's better to use them instead of using empty spaces.
Exactly. You should avoid empty spaces and also special characters, like in this case, the brackets in option A. Yes, exactly. Here is just a summary of all the aspects to consider when naming a file. So the naming should be consistent, always use the same components in the same order, then write down the naming convention so that all colleagues can follow and use this convention. The file name should be short and meaningful, so you know about the content without having to open the file. You don't have to repeat the folder name because it is already included in the file path. Then, as we just said, avoid special characters and spaces. Here are some alternatives like the snake case, camel case, and kebab case. Agree on a date convention and number your versions. Some further remarks about version control. It helps you to track changes and to compare them over time. It can be particularly useful when you collaborate with others in the same file or even at the same time. Some versioning software allows to branch project and then make changes and then integrate them back in the parent project. You can also easily revert the previous state of a file if needed, or if a file got lost or corrupted, you can still access a previous version. And there's also some useful versioning software like the Tum Workbench again, or Git, or Apache Subversion. There's still a hand. Do you have a question, or is it the hand from before? Okay. So you have seen that a proper planning and organization already helps to prepare your data to be fair. Then let's continue with the documentation and metadata. Documentation can be very short and concise, written down in a README file, or if you use a lot of abbreviations, symbols, or codes in surveys, for example, you could use a data dictionary or code book. If you work in a lab, a laboratory notebook should be used. And there are also so-called data papers, in which you can describe in a very detailed way your research data, and then you can publish the paper in a data journal. Metadata are a subset of documentation. There are data about data. You need metadata in order to find and understand the respective data they describe. And of course, the findability is much better if the metadata are machine readable. And what makes data machine readable is the use of a standardization, which means controlled vocabulary, because it reduces the ambiguity of the normal human language. Here you can see different types of metadata, like descriptive metadata, necessary for the findability and correct interpretation of the data. Then administrative data, like technical metadata indicating the file type or size or the necessary software. Preservation data like a checksum. Do you know what a checksum is? We have an IT expert, so maybe you know what it is and can explain it. Or someone else? So before, when I showed you the publication procedure in Mediatome, I also said that we require checksums. So a checksum is a computed value which is used to verify the integrity of data, because during data transmission or a long storage period, data could be corrupted. So it works like this. If you want to publish something, you compute a checksum, send it to us, and we also compute a checksum of your data and then compare it. And if it matches, then nothing happened to your data and everything is correct. So it's a step of security. Another type of administrative data are rights metadata, like a license, and there are also structural data giving information about their relation to other data sets or other publications. The complexity of data can become very large, but this is not always necessary. It also depends on the domain in which you work. For example, in a private domain, maybe simple metadata can be sufficient, whereas in the public domain, you need more complex metadata. And the data can also change their domains, which means that at the transition points from one domain to the next higher one, you also need to fulfill higher requirements. So in detail, it means that, for example, in the private domain where you are the only responsible person for your data, maybe a good folder structure and file naming can be enough. In a group domain where several researchers work together, you should also agree on conventions and abbreviations, a consistent use of variables and things like this. In a permanent domain, the requirements are higher because the data should also be comprehensible if researchers leave a research group. So even more context information is needed. And in the public domain, there are usually data after a research project has been completed, and then the data is accessible for researchers from all disciplines. So in this case, you should follow metadata standards, which are often designed to meet the needs of specific disciplines. Is there a question? Okay, I heard something. Okay, so here I have listed a few links where you can search for interdisciplinary and discipline-specific metadata standards. For some disciplines, you will find more information than for others, because a lot of work is still in development at the moment, especially by the NFDE, the National Research Data Infrastructure, which develops standards, tools, trainings, and infrastructure in general in collaboration with scientific communities. So you can also have a look at those links. And there are also metadata standards specifically for software. Any questions so far? If not, we will proceed with the topic storage and long-term preservation. And here I would like to ask you if you have ever lost data. I have a survey. Yeah, you can see it. You can restrict the question to digital data. The survey is anonymous. Oh, okay. I give you some more time. So 2 people are still missing. So here you should see the results, and yeah, the majority of you has already lost data. So probably you know very well how important backups are, and we will have a look at them. Then I have another question for you. Which storage devices do you use in the context of research? Here, multiple answers are possible. So is it your computer? Is it a mobile storage device like a USB stick, or a network storage like the NAS drive of the LRZ? Or do you use a cloud storage? Okay, let's stop the survey. So most of you use a personal computer, network storage, and cloud storage. That's quite good actually, because mobile storage devices are the worst option. We will have a look at those devices in detail. So a computer is very handy, but yeah, you are responsible for the security and the backups. And if you don't know how to do it, how ensure security and backups, then it can also be a very risky solution. Besides, local drives may also fail. And if you are carrying around your laptop, it could also be lost or stolen. A mobile storage device is maybe easy to transport, but also very risky because it's easily lost, damaged, or stolen. The lifespan also depends on the chosen device. So, for example, a solid-state drive has a much longer lifespan than a hard drive disk. It also depends how often you use the device. So if you only store data on your storage device, then it lasts longer than when it is frequently in use. And another drawback is that the storage capacity might not be sufficient, and then you also need several devices. A network storage is sometimes combined with a cloud storage, so you cannot always clearly distinguish between them. It is the best choice because it ensures professional backups, implementation and maintenance, data protection and access control is ensured, and all in all, the risk of loss, theft, and unauthorized use is rather minimal. But of course, the security depends on the provider, and you need internet connection. A cloud storage is suitable for simultaneous collaboration. So here as well, the security depends on the provider, and you need internet connection. Now I would like to present to you the storage options offered by the Leibniz Supercomputing Center. The cloud storage is a very secure storage with backup options. Actually, snapshots of your data are taken several times per day, and you can restore the data from them. You can either mount the storage in your file system, or you use the web interface web disk. Then if you would like to store large amounts of data, for example, of terabyte size, then you could use the DSS, the data science storage, which is available via the I/O of your department. Then the ESA cloud storage is an archive which automatically deletes the data after 10 years. Actually, you have 10 more years to restore the data from the backups. And it is an archive which is not meant for frequent use, but rather to deposit the data. Sync and Share is a cloud storage which can be used simultaneously in different devices and is very useful for collaboration. And for all those storage options, you also have a backup system. Here you find some more advice on backup strategies. It is always a good idea to check if your backup system is working. So just restore data from backups to check if you can read them, if you know how to do it. You should carry out integrity checks to ensure that the data has not been corrupted. As I explained before, you can compute a checksum. If you use mobile storage device, you should replace them regularly. And there's also a 3-to-1 backup rule, which says to store at least 3 copies of your data on at least 2 different storage devices, and one of these copies should be at a different location. If possible, you can follow the rule, but you will see that it's not always possible because it can also be quite costly to ensure this rule. This slide is about choosing sustainable file formats for your data. It concerns particularly long-term preservation, and the goal is to choose formats that are likely to be used in future. So how you could ensure this? There is a rule of thumb which says to use preferably open source, simple, and widely used file formats. Here are some examples of recommended file formats, but also consider the formats which are used in your specific discipline. And then there's the question how to select research data for long-term preservation. You don't have to preserve all the data you produce. Choose rather wisely which data are necessary to replicate your research results. It might be, for example, more important to archive the tools or the software for creating data than the created data itself. But it also depends on the case, because if you need a high-performance computing center in order to run your simulations, then of course you should also store the produced data. Choose data which might be valuable for other researchers. And if you have data which is unique, non-replicable or expensive to create, then of course it's also important to keep them. And sometimes you also have to weigh up the costs of archiving against the effort required to create the data. And always follow the legal requirements, policies of your institution, research funder, or research community. So here you can see that storage and long-term preservation are also needed to find, access, and reuse the data. And the next chapter is about publication and licensing. Has any one of you already published research data? Yes? Where? Have you chosen a repository? Or?
Yeah, publish data on Triad and Figshare.
Mm-hmm.
And I think that's it. Yeah, I guess so, yeah.
Okay, so these are very general repositories. Arash Mirifa, you also said you published data?
Yeah, actually, I publish, and also I use these open source databases to share the raw data, and then there's the possibility to get a license. That's how you can. How do you want it to share the data with the?
Yes, a license is also very important. Yeah. So this is also something you should check before choosing a repository if they give you a license for your data. Here we can have a look at the reasons for publishing or not publishing data. So there are a lot of benefits. If you publish your data, your research results can be replicated and verified, which increases the transparency of research. Time and costs can be reduced by the reuse of data. It also accelerates scientific progress. And scientists can profit from a higher reputation. In fact, papers published together with research data are also cited more often than without the underlying research data. And if it's also often a requirement of publishers and institutions to publish the data, so as you are interested in publishing papers anyway, you save a lot of time if you already think about the data management beforehand. There are some reservations about publishing, like the fear of misuse or misinterpretation of data, good metadata and access control could help you if you have this concern. Wait with the publication of the data if patent claims might be endangered otherwise. If you are concerned about competition or you're planning to publish further papers based on those data, an embargo or access control could also help. And if you are dealing with confidential data or personal sensitive data, then you should anonymize them.
Can I ask you if research data is published in a general repository, is it possible to publish them together with paper later in a gold or green open access way?
Yes, well, it depends where you publish the article later on. Sometimes journals have special requirements, but the normal way is that you can publish the paper wherever you like, and then you include the link to your research data in your paper, and your research data are in a repository. So this is the normal way how it works, but you can also always check with the journals which shows. Any other questions? Well, here some more information for you in case your research data consists of personal data. First of all, by German law, we are not allowed to give legal advice. That's why you can see the disclaimer. So if you are unsure how to handle personal data, you can always contact the data protection officer of your department. I can just give you some general information, which you can also look up. So personal data is all the information relating to a natural person. And that could be, for example, your name, address, or an ID number. And according to the EU General Data Protection Regulation, it is not allowed to process personal data unless another legal regulation or an informed consent is given. And if so, you should always make sure to process as few information as possible and to protect it, ideally by anonymizing the personal data, because then the data cannot be attributed to a person anymore. So for example, by generalizing the data instead of stating the exact age of someone, you could give a period from, I don't know, 30 to 40 years, things like this. But it is not always possible to completely anonymize the data. So someone could still be able to identify a person, and on the other hand, you might also lose important information due to anonymization. So often pseudonymization is used, which means that with the use of additional information, so maybe a key or a table with a code, a person can be identified. And in this case, you are not allowed to process the data without the consent of the person. So you always have to find a balance between the protection of the personal data and the usefulness of the data. And if you anonymize the data completely, it might not be longer of much use. So always check with all the persons concerned. So this was just specific information for personal data. Let's proceed with the publication. There are different ways how you could publish your research data. Either the research data is attached to a paper or thesis in a supplement, which is not recommended due to technical and organizational reasons. Here you can also find some links with more information about this issue. Or the better way is to choose a repository. There are institutional repositories like Mediatome or generic ones like Zenodo, but the best choice are actually discipline-specific repositories, because for researchers of the same discipline, it's easier to find those data. You also get more context information and also links to related data sets. And sometimes discipline-specific features are offered. So, for example, if you have archaeological findings, you can also see a map with the exact location and things like this. And as I said before, there's also this possibility to publish a data paper in a data journal. So a detailed description of your research data, including the identifier of your data, and the data is normally also stored in a repository. Re3data.org is a registry of research data repositories. So if you are looking for a suitable repository, you can use those links. I can show you how it looks like. So here you can browse by subject and have a look if there's something suitable for you. So on the right side, you see what is offered by this repository. So here it's an open access repository. You can also get some licenses. On the left side, you have some filter options. And yeah, I would suggest that maybe you take some time, maybe 5 minutes, to have a look if there is a suitable repository for your discipline. I put the link in the chat. And yeah, just take some time to check it out. So maybe 1 more minute. And if you have found a suitable repository, it would be nice if you could share it with us. Okay, how was your experience? Did you find something or nothing at all? Who has found something for his or her research data? You can also share the screen and show us the repository you found.
Just to make a comment, I think for me it was very hard to search by keywords. So most of the time there was no result. And I think best option for this search engine is to use very simple keywords or search by content type, and then you have a structured overview about what's on this platform.
Yeah. In any case, if the keywords are too specific, it's always a good idea to choose a more abstract level. So more general keywords. Yeah. Any other comments?
I have some more experience that I put word shear stress and didn't find results. But if I put water or environment, there are many water repositories related to environment.
Yeah, good example, yes. Okay, if there are no other comments, we can proceed with some further information about the DOI, which I already mentioned before. So the digital objective identifier is the most prominent persistent identifier in science, and it can not only be used for papers and data, but also for events, for example, an earthquake. And a DOI is also very useful for the citation of research data. Here you also find a link with suggestions for citation styles. Then there's also a so-called concept DOI, because once a DOI is assigned, nothing can be changed anymore. So if you would like to publish a new version, you can either get a new DOI or you use a concept DOI that includes all versions, which is also very nice because you have all the versions together at the same place. And a concept DOI is, for example, offered by Zenodo and Mediatome. I can show you how it looks like. Here's an example of a DOI for an earthquake. And here you see an example of a DOI. So the blue DOI here is the concept DOI. And below you can see the different versions, and every version also has a DOI. So if you want to refer to one specific version, you choose the specific DOI. And if you want to refer to all the versions together, you can use the concept DOI, and it links to the newest version of the data. So then it's very important to state the conditions of reuse for your research data. For example, by using licenses, the advantage is that the conditions of reuse are very clear. People who want to reuse the data know exactly what they are allowed to do with the data without having to contact the author. And these aspects facilitate the sharing and reuse of data. When selecting a license, you should prefer a standardized license text and licenses which are internationally applicable and machine readable. There are different types of licenses. You can distinguish, for example, between commercial versus free licenses, or licenses can also vary in their openness from rather permissive to restrictive ones. And there are also licenses suitable for different types of data. For example, for software, there are specific licenses. The Creative Commons licenses are the most common one. They are built upon 4 elements, which can be combined in different ways. The attribution element means that the reusers are allowed to do everything they want with the data, copy, distribute, remix the data, if they give credits to the author. So if they state the author. Non-commercial means that you can use the data only for non-commercial purposes. Non-derivative means that reusers are not allowed to share derivative work. So that could be a transformation, modification, remix, or adaptation of the original work. And the last element, share alike, says that derivatives may only be shared under a license identical to the original work. There are 6 combinations of those elements. So on the top, you can see the most open condition, CC BY, which we normally recommend to use for your research data, which means that, yeah, they can be reused as long as the author is cited. And below you see more restricted combinations. If your research data consists of software, it's better to choose software licenses. Here you can see a range from permissive to protective licenses. And in case you are looking for an appropriate license, here are also 2 useful links. So now you have maybe a better idea of all the aspects which contribute to the fairness of data. So this issue about licenses is very important for the reuse. And with all the aspects we discussed so far, I would like you to check the fairness of a data set. So here you can see an exercise, and I would like to ask you to check if the data sets meet the FAIR principles. I will send you the link in the task in the chat. Just a moment.
And after the file is in the chat, please open it very soon, because yeah, so everyone can check it.
Yeah, check if you can open it.
Yeah, will you do breakout rooms, Katja?
Yes.
Okay.
So you will see not all FAIR principles can be checked straight away. So you only have to check the marked ones. And yeah, I will send you to breakout rooms. You can just click on the room, which will appear soon on your screen. And yeah, maybe one person of your group could just share the screen so you can have a look at the data set together and discuss it. And after 15 minutes, let's say about 2:20, we will meet again, and then every group can present their results.
Yeah, and you should try to open the file right now, because later on in the breakout rooms, you won't see the same chat as here. And so it's very important that you can open it. And we know that some people cannot do it. There's a question about from Arash Rifa.
Yeah, I'm just wondering, maybe you mentioned it, I forgot. Will we get the access, will we get a copy of the slide at the end of the presentation?
Yes.
Yeah,
I will send you a PDF file with the slides.
Thanks.
Okay, if there are no other questions, I will start the breakout rooms.
So everyone can open the PDF file. Is that true? Or is there anyone who cannot open the PDF file? So we should take care that in one group, at least one person can open the PDF file. Someone cannot see the link?
See it.
You cannot see the file in?
Yeah, exactly. Not the file and not the.
Hello. Hey, us.
Hello.
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 Bye.
can try to open the file. I can try it. Yeah. I save it. Just a second.
Hello. Actually, we are in room 2, so I think we should use the second link.
Okay, we have it now. Do you see that?
Yes.
BMRB entry. Yeah. What was the task for us? What we can do with this?
I think it's written in the document, right?
Select the metadata set attributed to your room. And here, do you see my screen?
Yes.
With the FAIR principles. This is the whole document. So we should check the metadata if they meet yellow marked FAIR principles. First one is metadata are assigned globally unique and persistent identifiers. Go back to the repository.
So the persistent identifier, that's the DOI, which is there in the center. DOI 10 13018, yes. So that's definitely there.
Second one is data are described with a rich metadata. Am I right that if I say that all this is data?
Yes. And then there's additional metadata actually below in the boxes, the green boxes, yeah, assembly, samples, and so that's additional metadata in addition to the metadata, yeah.
I think we can say yes to this question.
So you think we know what the metadata refer to, right? Which documents? Right? Are you checking the second or the third point?
Second.
Ah, the second, with the rich metadata. Yeah, I think definitely it's very many metadata.
Third one is metadata is clearly and explicitly included in the identifier of the data they describe. F3.
I think there in the top right corner, you see all files associated with the entry. So I think this means that all the metadata are relating to those files there. So in this sense, I think all the documents are identified by the metadata because they're in the same place. Right?
I think that metadata is the text
below, yeah.
Below.
Yes.
This on the top right corner is data sets, data files.
Yes.
Mm.
Exactly. And at least here, it's presented in a way that we see that those metadata belong to those data sets.
Yes, yes.
So I think the identification is clear in this layout.
Can you scroll down a little bit just to check if like how available and how much can we use this data? Thank you.
Use the file.
Can you go a little bit down?
Are you looking for a license?
Yeah, more or less like like if we have this information, can we use it all or not really? And something like that.
Yeah, so basically we're looking for license information. Maybe it's at the top. Good question. Doesn't seem to have a license. And I think that's one of the points that we have to check later, right? But yeah, I don't see a license.
But can we go for F4? Metadata are described or indexed in a searchable resources.
Yeah. So searchable resource might be something like Google Scholar, right?
We need to search this title in Google.
Yeah. Yeah, looks good. That's actually the article, right? And that's the article that is based on the data we have seen. So do we actually find the repository for the data sets?
It's called PMRB, Hierarchical Magnetic Resonance Data Bank.
Yeah, maybe if you add this in Google, maybe we find it. PMRB entry. Yeah.
Yeah. So it is second record in Google. If I put my
second result, yeah.
So it means that it's indexed in a Google. Let's say yes. F4. Can we go for interoperable part? Metadata use a formal, accessible, shared, and broadly applicable language for knowledge representation. think, as I understand, it is written in English, and it's keyboards,
and also it has a taxonomy ID. So there seems to be a kind of disciplinary standards in biology for mouse, maybe taxonomy ID 190. This seems to be a specific language that maybe it is easy to find, yeah, in this domain. Yeah, so definitely they use some discipline-specific language for their metadata. Seems like a metadata standard.
yes. So I1 can say that has taxonomy, right to keyboards, and it's findable, interoperable. And what I3 metadata include qualified references to other metadata. So I'm not sure what they mean. References to other metadata.
Maybe below there were some boxes, right? Maybe they have some meaning. What happens if you click on the green box for assembly, for example? Does it do anything? Or samples and experiments? Or is it just, what happens if you click on that? Ah, okay. But it doesn't seem to refer to other metadata, right? See, below you have related database links. Maybe that's something. I don't know what it means, but it's something related at least. Maybe it's different providers of databases, huh? What happens if you click, for example, on the DBJ? This seems to be a different repository. So it looks like it relates to other metadata, at least indirectly. Huh?
Yes. Okay. So we can say yes for this part.
Yeah, at least indirectly.
Thank you. And there is a part reusable. Metadata are richly described with a plurality of accurate and relevant attributes.
Yeah, I think we have already seen it's very precise metadata, very many metadata. So I think we have the plurality, I assume we have the accuracy and the relevance. So I think R1 is fulfilled, yeah. But then there's the sub points, right? R11, 12, and 13. So maybe we should check those.
Metadata are released with a clear and accessible data usage license.
And we haven't seen that yet, right? Not found it.
So we can maybe say in this case that we find it.
Maybe I have one idea. If you, I mean, I saw one of the files was a text file. If we can open this one, maybe the license is within the text file, you know? Inside, maybe. I think if you go back, yeah, you can click the link, yeah. I mean, for example, you see up in the right-hand corner, there's the second entry is a text file. If we can open this one, maybe it has some license in there. Or maybe not. Maybe at the end. Yeah, so it doesn't. If you scroll down to the very bottom using the scroll bar on the right,
The end.
yeah, that's the end. So I don't see any license. So this point doesn't seem to be fulfilled.
We can ask later if we can use this data set or not, maybe. We can ask.
Provenance. So do we know where the data came from?
The history of data. We have 1 second.
Okay, so how was it? Maybe, well, you were 3 groups. Maybe each group can present their results shortly. So let's start with the first group. Is there a volunteer who wants to present the results?
I guess I can do it.
Thank you.
Overall, we thought it was quite well made. I should share my screen, I guess. So this is this US Department of Agriculture repository, I guess. Overall, for the principles, there was the findable principles were all well met. So when we look at the metadata file for this specific record, we see that the identifier is very easily found because it's one of the first things we see, the DOI. The rich metadata, there is a lot of fields. It looks very standardized, and actually there is a metadata standard name and version number towards the end. So I imagine that is used through the whole USDA data repository. So I would say there is rich metadata, and it's standardized metadata. So the identifier is clearly explicitly included. I think this is also met. And for the registration or index, while we tried to Google it, and it was pretty easy to find. And also, of course, there is this repository with a search index, and that's we can search the catalog directly. So the whole repository is developed in a way that it's easy to retrieve the data set. So I would say findable was good, everything. Then for the interoperable, sorry. The metadata language, I think I already talked about this, but yeah, there is a standardized metadata language. So I assume this is the really state of the art for this field in particular, this type of data. And there is a reference to other data. Can see, for instance, how to access certain tools that are relevant to the use of this data, and it's they are given here. Also reference to publication which are relevant to these. So this works. And then for the reusable, for the usage license, we had a little bit of trouble because there is no actually record-specific field mentioning the type of license. But actually, I mean, it's not in the metadata neither. But there is actually, at the level of the repository, there is a condition of use that gives the license information. So basically, it's not record specific. So I guess this works. It's not the easiest thing to find though. So maybe half a point there. I don't know exactly how we scored it. And then detailed provenance. I think this was well. I mean, we thought it was well informed because the author, publication dates, the institution, publisher were all mentioned at the very beginning of the metadata. For the temporal coverage of the data, we thought this was maybe a little vague, but that might be because this is a characteristic of this data, but we just have a year and no specific date range. And for the relevant community standards, I don't know. I suppose I should know because I'm working in forestry, but I don't know. I guess that's like a domain relevant. It would we would first need to be familiar with these community standards, and I don't think any of us was. So not sure on this last point.
Okay, thank you very much. Yeah, I think it was very well done, and the data set is fair. And as I said before, there are different levels of fairness. So of course you could make it even clearer, especially regarding the conditions of reuse. But all in all, it's a very fair data set. Okay, then let's proceed with the second group. Is there someone who would like to present the set?
Maybe I can start.
Yeah, thank you.
We found the data are findable in all points that are yellow marked in the questionnaire. We found interoperable. We found that there are keywords. There is taxonometry related to the subject or the fields of research. And reusable, that there is a data set and all metadata and additional metadata to the data sets. We didn't find a license,
okay,
Creative Commons license in there.
Maybe we have a look. Was it this, the only point, or was there any other point which was not fulfilled?
Maybe that we try to search in Google if the name of the article is indexed, and we found it together with the name of the repository in Google.
Yes. Well, actually, if it's findable in the repository itself, then it's also a researchable resource. So it does not have to be Google. Maybe I share the screen. So here you could also search for the entry and you would find it within the repository. So this would also fulfill the requirement. And regarding the conditions, here it's similar to the first group. It's a little bit hidden. If you look here, privacy policy, usage policies on the left side, you see that all data files contained in this archive are licensed under CC0. That's the public domain, which means that it can be reused in any way. And in the second row, you see that reusers are encouraged to attribute the original authors to it. So here you can also see the difference between what has to be done and what is good scientific practice. Good scientific practice is always to state the author, so you're encouraged to do so, but you can freely reuse the data. So here, again, it's hidden, but the conditions of reuse are also stated there. Okay, any other comments about this data set? If not, thank you very much. And now the last group. Is there a volunteer?
Yeah, I can.
Thank you.
I'll just share my screen. Maybe the others can also say something. If yeah. So that's the that's the thing where we had a look at, and here you can, when you click here, you can see the author, the title, the year, version, the DOI as well. It's quite short, but I think quite informative. What else? Yeah, and in general, I think there's a lot of description in the for the different requirements, and oops, sorry. Oh, sorry, just doesn't. Okay, now I can see it again. Yeah, and you can see maybe the others can help me where it was. There is information about the licensing.
If you click on the terms, yeah.
Yeah, on the terms, that's it. Yeah, here. Yeah, then there's a link to another website describing quite, I think, well, what you're able to do with the data and what is not okay. So you can't use it commercially. Yeah. What else?
If you click on the files, also you can show the type of it.
Yeah. Mm-hmm. Yeah, and here you can see the different files, but what we found is that the description of the single files is not very clear. So when reading the titles, you don't really know what's inside the files. But maybe it's also because we don't have any idea about the topic now. But yeah, I don't know how far this should go. But there's no date, for example. No.
As you can see, there's metadata, right? So maybe if you click on those, you will find some content information.
Yeah. Okay. Yeah, maybe you have to download it, because like here I can't click on it, but that's a good idea. Yeah. Maybe you have to download it for that. Yeah.
Yeah, or if you click on the title, you can also access the metadata, the title of every file.
This didn't work before. Okay.
So yeah, you can even see the versions, metadata and versions. So it's also quite detailed for every single file. Yeah. Okay, thank you very much. Do you have any questions about fairness of data? If not, we will proceed here with the guidelines and policies. Just a quick overview. There are different types of guidelines and policies. Some relate to research in general, others to funding agencies or a specific program, institution, discipline, or journal. And I will just give you a few examples. Here is the Dfg Code of Conduct for safeguarding good scientific practice. It consists of 3 levels. Actually, I can show you the website. Here, it looks like this. You have the different principles, And some of them also relate to research data. So for example, here documentation is of course also important for research data. Here you have the guideline, then an explanation about this guideline, and on the right side you see specific information for various disciplines. So, and all those principles are relevant for research projects in every institution, also here at the TUM. Then there are funder-specific guidelines regarding research data management. The DFG, German Research Foundation, for example, published a checklist with requirements related to handling research data. Actually, last week, the DFG declared that this checklist will now be mandatory for all DFG proposals. And as you can see, the topics we discussed today are all part of this checklist. Then there are guidelines for specific programs, for example, the Horizon Europe program of the European Commission, where a data management plan for fair research data is required, and data should be made publicly accessible as soon as possible, and also as open as possible and as closed as necessary. There's a question.
Yeah, I'm just wondering, I've heard from a colleague that when, for example, you design a graph, you have a model, for example, or something like this, maybe it's better that before that you publish your model as in, for example, peer review journal, that sometimes there's a kind of a rule that you cannot use, even as an author, this material later on without the license. So to have it in one of these repository and then produce a license that you can later on use it, that's correct? Is it possible to do it in this way? So before that you publish it, so you upload the model or the graph, whatever that you have, as in one of these the open access storage, and then produce a license for that you can yourself or some other people to use your model or graph.
Yes, well, you can use it, and when you select the data which you want to publish, then at this point you normally already choose a license. And as soon as you assign a license to your data, you cannot take it back. So once you chose the license, it can be reused according to the license. So this is the procedure.
But I mean that, for example, imagine that you create a graph, okay?
Yes.
And then you want to use it later on, but that graph is a part of the paper that we are going to submit in one peer review journal, and then it might happen that, so based on the rules of the journal, you won't be able to reuse that graph.
Okay, I understand. So this is what I meant before. You have to check with the journal first, what are the conditions. But usually the author is allowed to reuse the data. But of course, you have to check with the journal first. Yeah.
Okay. Yeah. So then
to make sure. Yeah.
Yeah, because in his case, he was complaining because even as an author, he could not use the graph in his PowerPoint for the presentation, and he said that I need to kind of change it a little bit.
In this case, there were probably some restrictions from the journal. Yeah.
Okay.
Another question?
No, I just wanted to comment on that. As far it probably is different for each field, and I'm not sure how it's about graph, but normally if you have preview paper for a journal, for example, I know that many authors are just publishing or putting in repositories actually the version before the preview. And that's a way how it's quite often sort of done, because the preview version, if it's the preview version, it's your version, but after the preview, obviously it's the journal version.
You're right, but you have to be careful. It's different with every journal. We have, I don't know if you know Electronic Journals Library. That's a platform where you get a lot of e-journals, or a lot of libraries contribute there. And there you get Sherpa Romeo. And Sherpa Romeo are the general, there you can find the general conditions of a journal. If this journal allows you to put somewhere a preprint or postprint. And there you can see if this journal allows it or doesn't allow it at all. So to not get in difficulties, check Sherpa Romeo, this is first, and then check your contract, because it could be different in your contract. So it's really a really difficult subject. And if you give a license to something, it would be easiest to just use your things, the things that you did. And if you use things from other people, be careful. Maybe it's best to ask them, or the journal, like Katja said, because it's a very difficult subject there. We know that about citations and things like that, and if you have that, especially with the licenses, it's very complicated.
Yeah.
And yeah, it would be best to make sure as possible that you can use it and ask.
Thank you for the comments. So always better to double check and to ask the journal, so then you are on the sure side. Yeah, we will continue with the guidelines. And I don't know if you know, we at the Technical University of Munich also have some guidelines for handling research data. And they tell you, for example, to manage your data in accordance to relevant disciplinary standards. So this is very broadly described, but you should also write a data management plan for every research project. And the head of a project is responsible for the research data management within this project. Then there are also journal-specific policies regarding research data management. For example, the PLOS journals require to make available all the data underlining the findings. And one more example, there are discipline-specific guidelines like the Human Genome Project, which required to make sequence assemblies available as soon as possible after the discovery. And this was one of the largest collaborative biological projects in history. And it was completed by determining all bases in the human genome. So any questions about research data management? If not, I will present to you the services offered by the university library regarding research data management. Apart from all the courses, which you have probably seen on our website, we also offer individual consultancy. So if you have any questions which were not answered today, you can always contact us. For example, if you write a data management plan, if you're applying for funds, or you want to write a policy for your department or things like this, you can contact us. Besides, the university library offers the Tum Workbench and Mediatome, which we already talked about. So I just briefly show it to you. You can publish all kinds of documents, for example, your habilitation thesis or videos, images, and here on the left side, you see the research data. And you have various filter options by subject. And I also described the publication procedure at the beginning. So here you can see which steps are needed to publish your research data here. So Mediatome is a repository which is suitable after a project has finished. So everything is done and you publish the research data. But during the project, where you still maybe annotate, describe your data, share your data, discuss it, and so on, you need another solution. And for this, we developed the Tum Workbench. This is a software which supports you in research data management and project management. It is a platform where you can just log in I just show you how it looks like. You have several different features like a calendar, tasks, projects, files, and so on. You can create projects and invite other people to it for collaboration. There's a question.
Sorry, I didn't want to interrupt you. Just it came to my mind because mostly we are kind of like on the temporary contract, right? So if we upload this data here, create a folder, a profile, and then for how long after the termination of our contract we can have access to this the data?
Okay. It's like this. You can also invite external users. So first of all, you have access to your data 2 years after your contract has finished. And then you could also, I mean, we sent you an email, and then you could also log in as an external and use it later on as well. So you could still access it, but we would give you a warning before it terminates. So you could still download your data or export them. Yeah.
Yeah, because for example, I am collaborating with one of the colleagues who is right now is not a member of the Tum anymore. So we use the sync and share for sharing the data. But after 3 months, he kind of cannot have access anymore to the sync and share. And then right now we are thinking to use another platform to freely use for sharing the data.
Okay, so you could use this because you will have access several years after the termination, and even then there are more options and you will be warned beforehand. And all the data you store here in the Workbench are also stored on the servers of the Leibniz Supercomputing Center, which is also very secure, and there are regular backups. So this would be a good option. I will just show you some features. For example, here a project management tool where you can create a Kanban board, create tasks and move them around to have an overview over your project. Then there are templates for data management plans where you see the specific information about your data and you fill in those fields. You could also export it and integrate it in a proposal, for example. Here for you just to see how a file looks like. You have a version control, you see the recent changes, which is also very useful if you collaborate with others. You can create a laboratory lab book, or if you don't work in a lab, you could use it for notes, like a notebook, and several other features. We also offer courses for introductions to the Tum Workbench. And the next one is this Friday. So in case you are interested in the Tum Workbench, you could participate on Friday, and I will give you a detailed introduction to the Tum Workbench. Okay, so that's all from my side. Now my colleague Hedi Becker will give you some more information about courses and offers of the university library. And meanwhile, I will also post you a link in the chat where you can evaluate this course. Yes, and now I hand over to Hedi Becker.
You will have to stop your screen sharing.
Sorry.
Thank you, Katja. Okay, then I share my screen. Maybe those of you who have been to other courses of the library know this already, but we repeat happily what we can offer to you. So in case you are, that we offer a lot of courses, and in case you have to take care of students, you don't have to tell them what to do when they do a literature search. So we have courses there for them, Literature Search 1 and Literature search too when they're doing their seminar papers. So feel free to send your students there. We give you a confirmation of participation to them, so you can see that they passed the course. We these semesters or these years, we have the courses as webinars and e-courses, so they can come via Zoom to our courses or do them in Moodle, and we give them a confirmation when they have done a small test. We also could tailor courses for your students if this is necessary, but they also can use our general courses there. There is this reference management software. As long as you are with our university, you could use Citavi and EndNote for free. There are the campus licenses for all students and for all employees, for the whole staff, for all scientists of TUM, so you could use them. Also here we offer courses. If you're not sure which program to use, you could use the comparison. We do an update for those every 2 years. And there's also a reference management and citation consultation. So if you have problems with citations, like we talked about also with the licenses, you can talk to us and we try to give you hints and help you there to do it properly. Then we have this course Cite It Right, where you learn within 2.5 hours to get a good feeling how you have to cite, how to do a proper citation. There's this citation guide. This is a now, meanwhile, 60-page long guideline for citations with different chapters about pictures, about graphs, about everything. You can imagine all around citations, so you could use that in German, English, and French. There are courses, no, they are not just in German. There are just once a semester is a course in English for citing, and this drop-in session for citation. This, I just put it in German because this is a course which will be only in German, because it's about German copyright and what you can do, what you can upload on Moodle for your students and what you have to take care of. We tailor the courses for your department, for your students, whatever you like. Just get in touch with us. Then there is this course, Compact Course Literature Research for your dissertation. This is also okay for scientists to participate. We show you search strategies, which database we offer, where we offer, how we offer them, how you could use them. There are German courses for different subjects. In English, we have a general course and a course with the focus on medicine, which is the one which is accepted as a course about a good scientific practice from Tum Medical Graduate Center. So this is good to know what search options we offer, how to get access to full text and so on. So it's more compact than literature search 1 and 2, and also focused on doctoral candidates and scientists. Then there's also a consultation session when you find out that this course was not enough for you, or you have special problems with your search strings, or do a systematic review. Feel free to get in touch and make an appointment for a search strategy and database consultation, and then we find out what would be best for your subject, how you do your strings, which databases you should consult there. Then is this course for the visibility, make you visible as a scientist. This is first part of is about academic identity management, the visibility of authors, if you should use an ORCID, or yes, you should use an ORCID ID, how you can compile your publications, about the publication guidelines of TUM, what you should do if you publish, and how you should put down your department and the technical university as an affiliation to take care, about the affiliation. And then there is this bibliometric part where we talk about H-index and impact factor, how they are built, how they are to be judged, or you can find out how to judge them, and so on. So this is a 4-hour course where you, next one is next week, but it's all already booked out. We have 3 further courses next semester. Okay, there's also a consultation service around this course. So if you like, you can come and let yourself get some information, especially on your field or your subject. Then there's also this course, Routes to Publishing, about peer review process, about publishing at our university, publishing your thesis at our Tum University Press, and so on, publishing on Mediatome. And then there is this course, Predatory Journals and Conferences. So be careful not to go to a predatory conference or publish in a predatory journal, because this publication is kind of burned. You cannot publish it a second time if it's not published in a proper journal. So what to do, how to prevent this, we show in this course. Then Katja already showed you our Tum Workbench as an example for an electronic lab notebook. There's also a course this Friday, still places available, course Tum Workbench, and there we take care a bit more than she did before for about this workbench, how to use it, what options there are. It's a 1-hour course, and it's on Monday morning at 9 o'clock, I think. Yes, just click on the link and register yourself for this course. So that's it. If there are questions, just all around the library, ask our first level hotline from 8 o'clock in the morning to 6 o'clock in the evening, Monday to Friday. And if you have questions about this course, about this subject, feel free to answer to the presentation I will send you very soon. Ask for a confirmation of participation if you like, or if there are further questions, you could ask Katja Kessler or ask our consultation, research data management. And if you write to me, I'll send it to my colleagues who are in charge. So the evaluation here again, further pages, website, tum.de Forschungsdaten. You could also click then on EN and check our website in English, and feel free to write an email there if you have further questions about research data management. So that's it from our side. Is there a question? Okay. Good. Then, yeah, thanks for coming. You still can ask your questions. You can stay also if you have a personal question, or if it's just your own subject. If not, Katja, do you have any comments still?
No, as I said, you're welcome to join the course on Friday, because the workbench can really be very useful for you. And yeah, you can always contact our team if you have any questions.
Okay, then thanks for coming. In a few minutes, I will send you the presentation. Have a nice afternoon, and maybe we see each other in the next course. Bye-bye.
Bye.
Thank you very much.
Thank you. Bye.
Bye.
Bye.